So finally we have such a relational schema diagram. That is our goal to design our database system. So this is up to this part is a design. Okay. So through the conceptual design and relational design, we have the relational schema diagram. It's kind of the blueprint of the house too before you build the house. Actually, when you build the house, you should have something the design and the outline. So that design is such a thing. So to build a real house, you need a tool or you need a material. So it is called the operation in terms of a database model. So when we discuss about the definition of the model, what is the modeling? Model means it's a group of concept, group of the rules. So actually the computer is not like the human being. So if we train the human being, we can say that this is what. Then sometimes you can infer, sometimes you can learn, you can be trained. And sometimes you are very creative. Even though you do not learn the something definition, you can imagine. Unlike the human being, computer can understand only design, okay, or the formatting. So that format, that design can be restricted. It's kind of constraint. In other words, it's a concept is the design model. So we have learned such a modeling and design. So sometimes not very detailed, but such a details, the information you can learn throughout the semester when you are using such a database system, database model. So this is our design. Then the next step is how are we going to build a house? How are we going to create a database based on such a concept? To do that, we need to learn such a group of operations. So in terms of operation, so we have learned first what? Can you remember the first operation that you learned? Such an operation, all the operation, relational operation will be based on our relational model. Okay? That operation will not work for the object-oriented model or the natural model, any other model, only for relational model. First, such a relational model, first one is we need to, anyway, we should be able to access the data. Where are your data stored? Relation, okay? What is a relation? It's a group of data, row, group of tuple, and group of attribute. So in terms of group of data, as a definition of the relation, we should be able to access group of tuple, group of data. How? The first one is selection. This is the selection operation, so we can access this is the table, this is the relation, is a group of data. We can access this group of the data. Okay, this is a select operation. We are going to use the sigma in Greek, the character. So, for example, we can use the condition. Here we can put the condition and the relation will be here. So, for example, so we can access employee whose department number is 4. Then output, you should be careful. The output of such a relational operation is also it's a relation. We can name. So this is another operation that you learn. It's the rename operation. There are two rename operations. One is rename of the relation. So you can rename this is a relation, but it's a little bit complicated to explain. So you can rename as R, for example. You can rename as you want. It can be R, it can be S, it can be temporary, it can be R1, R2, whatever. Okay? Then later, this relation can be used for input of another relation later. Okay? So this is a select operation. It also allows the commutative associative rule. So you can use such a logical operation in the condition like that. Okay. The next operation is projection. So projection. Projection is we are going to use the capital letter of the pi. Okay. So according to the definition of the relation, we can view the relation as a group of tuples, which means so sometimes we would like to access a specific the attribute, right, of the relation. We don't need any other information, only the name and ID only. So how can we access such a data? By using this, the pi, project operation. This project operation, so we can put the list of attribute. Input is R, like that. For example, so why don't we use this employee as the output of this one as the input? Then pi, I need first name, and middle name initial, last name of R. Then you can use the select operation inside. Okay? You can simplify. Then also you can rename to the other relation. Okay? The any output of any relational operation is also relation. So we can use that. Before that, we learn another. This is the rename of relation. We have another relation that is row. This is a row. R-H-O. Row. So row operation, we can rename attribute. So if those who already use the database, the query languages, SQL languages, you have used the rename of the column sometimes. The column name is complicated, it's too long, so you change. It's the same thing. F name is complicated, so I like to use FN. Middle name initial, MI, and the last name, LN. You can rename the column name, attribute name using row operation. Then you can also rename the result, like this one. Okay? So this is the, we already learned the select operation, project operation, and this is a rename of the relation, rename of the attributes.
The difference between both two, for projection, we can select columns. For
yes,
selection,
that's the column, like this one. So first name, last name. So
and for selection, we can select a relation or a row.
Which one?
For selection.
For selection, it's by row, by data.
Okay.
So because when we define the definition of the relation, you can view your data as group of row, group of data, also group of column. So, but it is true. I understand the most of the commercial database system focus on this one more. That is called data-oriented, the DBMS system relation. However, nowadays this column-based, column-oriented database is getting important. We will see. I will explain later the why this one is getting important. Okay. So this is the main operation that you learn. And what else? Before that, we can. So this is a relational operation. This is also a relational operation, and this is a relational operation, and this one. So, however, you can combine several relational operations like this way. So if we add this one, we can say row Fn, Mi, the last name Ln, I, first name, middle initial, last name, or sigma E NO is equal to 4, then employee. It's exactly same. Okay? So this is called relational expression. So just like the sentence or paragraph. Okay, by grouping word, okay, you can make the sentence. Or by grouping the sentence, you can make the paragraph, a paragraph. Paragraph consists of several sentences. Just like that, the relational expression can consist of several operations. In this case, 1, 2, 3 operation. It doesn't matter, exactly same. Okay? So the output are the same thing. Okay? However, later when we learn query optimizer. If you can understand what is a query optimizer, don't worry. So we will discuss later after midterm exam. However, query optimizer will find fastest way to access the data. At that time, the query optimizer consider operation by operation. Your input of SQL is like the query, the relational expression. However, this relational expression will be decomposed to the operation by operation. Then later, query optimizer will see operation by operation. Which one will be faster? That is a query optimizer. That is the reason relational algebra is important to understand the query processing later. Okay, and what else did you learn the last class? We have set operation. Set operation, the union, intersection, minus. And also one more thing, division. Division is a little bit different. We do not have the division operation in set theory, but it's similar as divide. Okay? So, first, union. It's the same concept as union in set theory. So, all of the A or B. Okay? And intersection A and B. And A, not B. Okay? You should be careful first, type comparable. Because this is called unary operation. Unary operation means deal with only one relation as the input. On the other hand, this one, two input. Two input, two input, two input. Okay? So, two inputs should be type comparable. What does that mean, type comparability? Should it be the same? Same type? In terms of the relational model concept, actually, there is no data type. Instead, domain. Okay? So as long as they are in the same domain, then it's called a type comparable. Even though, for example, first name and last name are different, but they can be type comparable. However, if the data is number one and the last name, they are not type comparable. If you can change automatically, that is called considered as a type comparable. So when you are using the set operation, the binary operation, first one, type comparable. The second thing is, it's not only for this problem, all relational operation problem. Output of relational operation is the another relation, right? I mentioned many times, which means the relation, do you think the relation allow the duplicate data? According to the constraint that we have discussed, each relation should have the primary key. That means unique and not null. Okay? That means output should be unique. There is no duplicate data. In case of the duplicate data, you can eliminate automatically. That is another thing you should keep in mind when you learn the relational operation, which is different from the SQL. I will explain later. We will see later. So that is a set operation and division. You learned about the division. For example, I divide by S. I has A, B, C column, and the S as the D, C column. So the return of I divided by S is the A and B. Okay, that include all A and B. Okay, all the tuple A and B, that include the A and B, at least A and B. That is the division operation. Is there anyone who ever used the database language SQL before? Any time? No one? Then probably you don't know. So this division is not implemented in our current database system. When Dr. E.F. Cote proposed the relational model, he proposed this one, but no DBMS. Actually, the commercial DBMS use this. The main reason is it's a little bit complicated. So most of the operations are straightforward. Complicated. Complication means it's expensive to implement. If somebody uses a lot, so it will be your system will be slower and slower. So this is not practically used, but you can understand the meaning of this operation. Okay, so that is a set operation. Another set operation that you learn is this one. What's the name of that? It's a Cartesian product. So why don't you equal your knowledge on the set theory? When you learn the set theory, so you learn about the Cartesian product. For example, AB Cartesian product, the 1, 2, 3. That is four combination: A1, A2, A3, and up to B3. That is a Cartesian product. That is the same thing in relational database. So when we have the R and S, or combination, for example, R relation, employee, we have 8 employee and we have the 4 department. How many output of the Cartesian product? 8 times 4, 32. That is a Cartesian product. Like this one, 2 times 3, or combination, or possible combination. That is a Cartesian product. Cartesian product is practically used in the database languages like the SQL. So we will see later. So that is a Cartesian product. Cartesian product is the or combination of the 2 tuples. Okay. Then eventually we learn very important operation. That is Cartesian product plus selection operation. For example, select the D number before DNO of employee Cartesian product DPT. Like this one. What does that mean? That makes sense, right? Because Cartesian product R and S, 2 input, then output of this one, Cartesian product is also input of select operation. Then select operation is D number is equal to DNO. What does that mean? I'd like to return the employee plus department information who works for specific department. Okay? Not exactly same meaning, but roughly. So we will see the example of that. So let's say, suppose that we have the employee, we have the name, simplify, address, and D number, DNO. Okay? And also department, we have the D number, D name. When we first Cartesian product employee by department, it will be like first name, address, DNO, plus D number and D name. Then, for example, we have the name Lee, address 57 Tower View, and DNO is 1, D number is 1, D name is HR. Okay? Then also if we have the 2 department, 1 and 2, the HR and payroll. Another one is the Lee, because it's all combination. Lee, same address, and DNO is 1, it's a 4 employee up to there. This is the department 2 payroll. We have the James. James is 100, the University Avenue. Department number is 2. First 1 and HR. And also James 100, University Avenue, and 2 payroll. So this is the output of Cartesian product or combination. Then apply select condition. What is the select condition? D number is equal to D number. Is it okay? Yes, this will be written. This is okay? No, this is not written. This is okay? No, not written. This is okay? Yes. Satisfied with such a condition. Okay? So which means only met the tuple that satisfied with the condition, select condition D number is equal to DNO will be written. Okay? This is usually used a lot in relational model. Why? We will see later. So after we learn the normalization. So at that time, we can simplify that operation, two operation into. Is there any specific name of that symbol? I mean the general.
Oh.
It's a ribbon or butterfly, whatever the name is. I think the database type made this symbol because it's from the Cartesian product, but it's so this is called join operation. So join operation, one of the main characteristics of relational model operation. So cannot see join operation in other the database model. Selection, yes, you can do. Projection, you can do. However, join operation is not used. So this is one of the main characteristics of the. So because of the some the developer use a lot of this join operation, then you can simply retrieve any data you want. That doesn't mean it's good. The database, the database language. We will see why later. Anyway, keep your mind. This is a join operation. Join operation exactly same as Cartesian product plus select operation. Okay. So this one can be simplified, and it's the same thing with employee, join department, and join condition will be here. D number is equal to Dn. So this is called join condition. So join condition at that time, sometimes if you cannot, it is possible. This column and this column name are the same. It doesn't matter. Okay? In case if you wanna specify the name, you can use notation that you learn. Employee dot DN. Department dot D number. So you can use that. It doesn't matter. So anyone. So like here, so you can use the relation name dot the attribute name. Okay. So this is the join operation. You learn the different types of the join, right? Do you remember? No?
Let's join from the right join.
So first, equijoin.
Oh.
Okay? Do you remember that? So equijoin. This one is equijoin. If your join condition has the equality, it's equijoin. As name implies, it's equijoin. That means inequality join may be possible. You can put any condition actually here. However, equijoin is the most general the operation. Okay? Because for example, if you want to use this one, yes, if DNO, D number is the number, then you can use. As long as the tuple satisfied with the join condition, it can be written. Otherwise, discard. So this is called equijoin. The first one is equijoin, and second one is natural join. What does it mean? Natural join. Natural means we have the unnatural join. Natural join means sometimes if you see the data model like this one, let me change DNO as the D number, which means this D number are identical. Okay? That time we do not specify the join condition. So if you use natural join is like a star, like that, natural join. So That is, you can join if you have the same name, common name of the column, which is not natural in DBMS system, the database system. In the database system, they support the natural join. Not many people actually use the natural join. Instead, you use just the normal join operation. Okay, that is the equijoin and natural join. You probably see the theta join, but the theta join you don't have to worry about too much. Okay, and after that we have something left outer join, something right outer join, or full outer join. Okay, so we will see such a thing. So here, so why don't we use this one? We have the two employee. One is Lee, another one is Lee, James, and Patel. Patel address is the 101, the Main Street. Unfortunately, Patel is not assigned any department. So this one is the 57, 100 University Avenue, and the 1, 2, and it's a none. Okay. At that time, if you join this one, you may have the two more. Okay. So Patel, this is 101 Main Street, null, and this one is 1 and HR. Next, partner, same thing, 101 Main, null, 2 is a payload. Do you think it will be returned with the join operation saying this one? Not this. It's the D number. DM. Can it be returned? No. Because you cannot compare null data. No way to compare. So definitely not. What about this one? Definitely not. So it will not be. Only two data will be returned using join operation. However, sometimes I want a list of the, I try to focus on the employee. So I want to list a report, like the report of the employee. Okay? Employee information and plus department information. Even though this Patel is not working for any specific the department, I want to see the left-hand side or the employee. At that time, we can use left outer join. Left outer join means I try to keep all left-hand side the data, whether or not it's null or not. Okay, so including null, all left-hand side. Then what about the right-hand side? There's no matching data. Right-hand side will be null, 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 null. You can keep the null. So output of left join. So this is the left outer join. So I will keep all left-hand side. So this one definitely not because it's not matched. This one is not. Okay. So this one is not matching. So we need one, but the other column will be automatically null. Then return 3 tuples. This is a left outer join. This is outer join. Outer join means I try to keep all null data because null will not be compared. It's automatically discarded by join operation. However, if you want to keep such a null data, it can be used by the left outer join. How can we represent the left outer join? So you can use this one. Keep the left hand side. Similarly, right outer join. Right outer join, I have 3. No. I'm not 3. And this is the admin. So let's see, we have the 2 employee and 3 department, like this one. Only these 2 and these 2 will be returned. However, if I keep right and side, same idea. So null data will be returned. How can 3? I think this one should be returned. So 2. This is a payroll. 3 and admin. This one will be null. This one will be null. This one will be null. Like that. This is a right outer join. So right outer join, we can use this side. Then, if I want to keep both sides, null data will be included. Then full outer join. This is a full outer join. So in later when we learn the SQL, it will be really left outer join. This is a syntax, right? Outer join or full outer join. Sometimes it's a little bit complicated. Some of the DBMS, including Oracle, later use plus sign. Plus sign means left outer join. If I want to include the left hand side, then left hand side you can put plus. Plus means plus null data. Okay? So later we will see. Okay. Pretty much that is the most of the quick summary. Any question? What else? The next. After you cover this one, what is the next? So, aggregate function. So, I think that it has been early 20, which means more than 20 years ago, almost 30 years ago, when the Oracle DBMS, Oracle was almost the first commercial DBMS, it's the most popular in the market. Okay, everybody go crazy. Why? Because it's too simple to make the report. Okay, one of the main functionality that the people like to use the SQL database language was such a aggregate function. Aggregate function means it's a statistical function. What is a statistical function? Average, mean value, average. What else? Maximum, minimum, standard deviation. What else? The variance, like that, or count, or sum. So this kind of statistical function is very easy, like when you are using the Excel sheet, like the Excel. So very easy to make the report, like the weekly report or the monthly report, yearly report. We don't have to calculate and summer, or we don't have to use the calculator. Just a simple the query language, database language is enough to get such a the output of the report. So at that time, there's such an aggregate function. So function, statistical function are used. Before we see that one, this slide shows the summary of what we have talked, what I summarized so far. Okay. Any question? The next one is aggregate function. Aggregate function is based on what? It's a group. Statistic means, so what is a statistic?
Group of data.
Group of data, just group of the data. We'd like to see characteristic of the data, group of the data. However, sometimes we cannot describe such a data simply. Okay? I have all the information about the student grade. How can I say this semester is good or this semester worst student? Okay, just to describe this semester is one of the worst semester ever I taught, something like that. No, that yeah. Sometimes you can understand how much. So to describe the data, we have used the statistics. So one of the main purposes of the statistics is to describe such a data. At that time, to describe the data itself, what is the data? You should limit such a data. You should define such a data. It should be grouped. Okay? So aggregate function or statistical function used in the database should be based on relation. Okay? Relation means it's a group. So group, and sometimes it's called a grouping function or group. So such an aggregate function always works with such a group. So for example, I'd like to see the average salary by the department. How can you do that? How can you get such a data? First, you need to organize the employee by department. So we arrange all the employee by the department number and make the group. After you make the group by the department, you need to calculate average salary, average salary, average salary, and average salary. At that time, you need two things. One is how are you going to make the group? Okay, group information. Then, what is the function that you are going to describe for each group? So, function and group. So, to represent such a grouping function, we need two information. One is grouping factor, left-hand side, and right-hand side is a statistical aggregate function. So for this function, sum, count, minimum, maximum, standard deviation, and variance, something like that. Okay, so that is the aggregate function. So for example, here, so this one, I'd like to see number of employees, average salary, or by what? Department number. Okay, so physically when you operate this operation, first you need to do grouping by the DNO. For each group, calculate this one. Then output of this one is grouping factor plus count and average. At that time, if you cannot understand the meaning of this, the aggregate function, you can rename. At that time, you can use the row operation. What about this? It's the same thing, but before group the rename. What about this? You cannot see the left-hand side. Then doesn't mean there's no group. Okay? There exists a group. How many groups? Only one. So input relation is a group. In case if you consider input relation as one group, you don't have to specify the grouping factor. Just the count. Count means all employees. How many employees? And average salary of this one. Okay? That time, be careful to count and average, maximum, minimum, for what? Null data. Null data cannot be counted. Okay, so if you count, that is the reason count social security number. However, if you count some phone number, it may be different, which means when you average null data, so it may be different. So you should be careful to use such a thing. Another thing you should keep your mind is how I explained how can it be operated. First, you need to group, then calculate the statistical function. How can you make the group? Just simply. So, for example, I'd like to make the group of my student by the date of the month of the birthday, okay? By month, okay? So January, who those who was born in the January, February, March, something like that. Okay? How can I do that? First, line up by DOB, right? Which means you need to sorting the data. You need to sort the data, right? Without sorting, you cannot actually group. So grouping require what? Sorting the data. What is a sorting? Did you learn the sorting algorithm? So what kind of sorting algorithm you know? Binary, quick sort, and so it is true. So if you have when I applied my job 10 years ago, so at the time I almost decided to go for the academia, but just in case, as a backup, I applied several the industry job. So Google was one of them at the time. There are several phone interview, but during the interview, I got the offer from the UB, so I quit the interview. One of the interview was for how many gas stations in United States? That's just question, without using any the computer. If I can see the computer because it's a phone interview, but probably I was failed right away if I answer correctly. They try to see analytical thinking. How can you guess? Okay? How can you predict something, the kind of the thinking, the power to predict something data. So for example, how can you guess the gas station in the United States?
Google it.
If you Google it, then you will be failed. Think about the roughly population. How many? What is the population in United States? It's probably 30 million and more than 300 million, something like that. How many of them are driving age? Driving age is 16 to probably 70, roughly, sometimes 80 or 90, but roughly the reasonable, the range. Then it can be the half of the population, let's say. Then how often you drive? A day or a week, okay? Then how often you refill the gas tank, okay? Then you can guess, and the range you can guess roughly the number of gas stations in United States, something like that, okay? That is kind of analytical thinking that I was asked. And at that time, I Googled what is the most popular, the Google interview question. Another one, which is the most frequently asked question, was the implementing sorting algorithm with a given condition. They provide the online, the Google, the script tool, then they sometimes change it, the existing, because you already know the most popular, the sorting algorithm. They change the condition, like you have only the single buffer or the limited buffer or the something like that. Then within the given second, you need to code. Okay, the code itself doesn't have to be correct, but in terms of algorithm, it should be correct. So sorting is very, very important. Why? Because it's a very, very expensive operation. It takes a time. So it's the same thing in database. It looks like a very good operation, but if you use a lot, which means your system will be slower and slower. So we will see such the example in database tuning at the midterm exam. Okay. So this is the already so the outer join. Yeah. So this is an example of the relational operation that we can. So first, when you make the relational expression, relational algebra expression, you need to understand the query itself. That is the reason I asked you in your the page 2, page 1, page 2. Page 1, make the plain in using your English. So make the possible query in plain text English. Okay, so that is this one. Then the next thing, so because you made such a query, you are the best one who can understand your query. But sometimes, so you cannot understand the meaning of this, then you cannot make the query. Okay, you cannot make the relational algebra expression. Before that, you should understand. So let's say, retrieve the name and address of all employees who works for the research department. You need to identify first what? Where can you get the data? Source of the data. In other words, name of relation, table. So I'd like to retrieve this information of all employees. That means we need employee relation. Then what will be the condition? So do you think the employee is enough to get all this data?
No.
Research department. Even though employee has the department information, it's only department number, DN. However, this one asks research, name of the department. Where can you get the name of the department? Department information. So department and employee, two relation we need to access. Then any other condition works for. Okay? Works for means the employee name and address. So this probably projection, right? And works for the research department. In the department is a select condition, only research department. And works for, this is a foreign key. So eventually, so first we need to get the all research department information. That is the select operation with department, D name is equal to research. At that time, single quotation. The database languages, including relational algebra and SQL that we are going to cover, they are not case sensitive. You don't have to worry about too much the upper or lower. But in general, there are rules for naming. But it's not strict rule. It's only for specific the group of the project or the company or the database system itself, but it's not in general. However, the only case sensitive applied in database language is inside the quotation mark. Okay, single quotation or double quotation means it's data itself, which means research and research are different. Okay, so you should be careful. Many of the students ignore importance of this one in midterm exam. Okay, so research, find that, rename. Say this is a research under by department relation. Then there are different ways. Okay, so however, this time you can use Cartesian product. Cartesian product with the research department and the employee. Then apply the select condition. That is this one, D number is equal to the DN or something like that. However, in this case, we use the join operation. So join operation is search department and under by department and employee. Then finally we can get such a result. This can be simplified as this one. DPT, department, and employee, and DNO is equal to D number, and others, the F name, middle name initial, last name, and result. This is also possible. That means there is no general solution. There might be general solution, normal solution, but only one solution? No. There might be many different ways. Even I can make more than 100 cases for this one. Sometimes I can add something, the projection separately, okay? So you can make as many as possible. So that is the reason. Also, you can make the one relational expression. Sometimes you can separate by the relational operation. So that is the reason sometimes after midterm exam, the many students complain whether this is not correct or this is correct or something like that. Because I'd like to check as long as the output are the same, so I'd like to give. As long as your syntax is correct, I'd like to give the credit. But sometimes not. I cannot identify the correction of the yours, so you can anytime repeat if you believe that is correct. Okay. So this is interesting. Retrieve the name of employees who have no dependent. What does that mean? Only single. Okay. Or sometimes the couple, but not having the dependent. Which means, how can we? There are a bunch of different ways. This one, but here we can get the social security number of the employee. So all employees social security number. Social security number of employee who have dependent, at least one dependent. How can we get the employee who do not have dependent? We can use the minus, right? Employee, all employee minus with the dependent, which means without dependent. So that is the without dependent. This is a natural join. Natural join, using the natural join, it will be based on the common, okay? Common, the attribute. At this time, the SSN will be used to join. But you don't have to use, you can directly apply pi over here. Doesn't matter.